So for these definite integrals, usually you just find the antiderivative and plug in the endpoints, except the one with the absolute value. This one will be easier if you just use geometry. But the first and last ones, you can easily find the antiderivatives, and you just use the fundamental theorem of calculus, which means you just plug in the endpoints and subtract. Now before we start, I want you to know this formula that if you integrate sine with ax in it, then we know that sine integrates to negative cosine, right? But this a in front of x creates 1 over a. And that's a common theme. So for example, if you had cosine ax plus b, that's 1 over a sine ax plus b. And then if you had e to the ax plus b, that creates 1 over a e to the ax plus b plus c. So you get these 1 over a's if you have ax. Notice that plus b doesn't do anything. It just appears at the final answer, and that's it. It doesn't create any coefficient. Only this a will create. So for this specific example, you would see that for this specific example, you see sine 3x. So you can think of this as sine 3x plus 0, where a is 3 and b is 0. And if you use above formula, this would be negative 1 over 3 cosine 3x plus 0 plus c. Okay, so this is a handy formula to know. The proof of this formula is by just using the u substitution. If you set u as this, then if you work out the u substitution, then you'll see that eventually you get this. If you don't like this, you can still just solve this by u substitution, u equals to 3x. But this is a shortcut that's very useful if you know. Okay? So let's do part A. This definite integral is therefore, you first have to find the antiderivative. Antiderivative of cosine is sine. Antiderivative of sine is negative cosine, and as I said, this 3 creates 1 over 3 in front. So we have 2 sine x minus 1/3 cosine 3x, and you have to plug in pi over 3 and 0 and subtract, okay? So when you plug in pi over 3, you get 2 sine pi over 3 minus 1/3 cosine 3 times pi over 3 minus, and then you have to subtract the one that you get when you plug in 0. So you get 2 sine 0 minus 1/3 cosine 0. And it's very important that you put these parentheses, because you have to subtract the 2, and without this parenthesis you will end up making these sign mistakes. Okay, so what's sine pi over 3? That's radical 3 over 2. And cosine 3 and 3 cancels, and cosine pi is negative 1. Minus sine 0 is 0, and cosine 0 is 1. And 2 cancels, and you get radical 3. That's plus 1/3, and minus that's plus 1/3. So you have 1/3 plus 1/3, which gives you 2/3 as your final answer. Now one more thing is, you shouldn't be putting plus c for definite integrals. Plus c should only be for these indefinite integrals. Never put plus c for definite integrals. Let's do part B. Here you're trying to draw the graph of y equals to 3 minus x minus 3. And the thing that you have to know is that absolute value graphs, they create V-shaped, and because of this minus in front, it will be an upside down V-shaped. And another thing is it's going to give you this turning point when this thing inside the absolute value becomes 0. So when x is 3, it's going to give you this turning point. And because the left and right points are 2 and then 5, we should also evaluate those and make sure that you know that the shape is 2 lines, okay? So let's come up with a table of values. When x is 2, then when you plug in 2, 2 minus 3 is negative 1, right? So we have y equals to 3 minus absolute value of negative 1, which is 3 minus 1, which is 2. And when you plug in 3, it's 3 minus, when you plug in 3 minus 3, that's 0, right? So this will be 3. And then when you plug in 5, it's 3 minus 5 minus 3, which is 2. So it's going to be 1. Okay, so what is the graph? The graph is that at 2 you get 2, at 3 you get 3, and then at 5 you get 1. And make sure you connect them by these two straight lines. I know that it's an upside down V-shaped. And because the integral is asking for the area under the curve, we have to find the area under this curve. Now you can calculate this in several different ways. One way to do this would be like compute this trapezoid and compute this trapezoid. So that's one way to do it, and hopefully you know how to calculate the area of a trapezoid. Or another way to do this would be like, think about this rectangle, 2 to 5, this is 5 minus 2 is 3, right? Whereas this height would be, this is 3 and this is 0, so it's 3. So overall, this entire thing is 3 times 3, which is area is 9. And then you subtract this corner, and as you can see, this length is 1 and this length is also 1. 2 to 3 is 1, 2 to 3 is 1. So you end up with 1 by 1 triangle, and then subtract, and this would be 2 by 2 triangle, because 3 to 5, that's 2, and again, because this is 1, 1 to 3, that's 2. So you have a 2 by 2 triangle. And we just use the formula that area is base times height times 1/2. So it's 9 minus 1 times 1 times 1/2, that's 1/2. And minus 2 times 2 times 1/2, that's 2. And the answer would be 7 minus 1/2, so 6.5, or 13 over 2. So that's the answer. Just to give you some idea of how hard it would be if you were to actually do the computation, first I have to tell you that absolute value of x is not equal to absolute value of x squared. You wish this would be true, but unfortunately that's not true. Okay, this is not right. What's needed, if you were to really just do this without geometry and just do by calculation, would be that you have absolute value of x is a function that gives you x when x is 0 or positive, but when x is negative, you have to put in a positive number. How do you turn a negative number into positive? You put a minus in front. Okay? So don't be fooled by this negative. Negative x is positive because we're assuming that x is negative. So this is the definition of the absolute value of x. And if I replace x by x minus 3, then it would be x minus 3 absolute value equal to x minus 3 or negative x minus 3 if x minus 3 is greater than equal to 0 and x minus 3 is less than 0. So if you compare these two, all I did was I replaced all the x's by x minus 3. And then you again have to do 3 minus absolute value of x minus 3. That would be, you're subtracting 3 minus x minus 3 when x is 3 or greater, and 3 minus negative x minus 3, so it would be 3 plus x minus 3 when x is less than 3. And so the outcome is that the function in question would be same thing as 3 minus minus 3, that's 6 minus x when x is 3 or greater, and 3 and 3 cancel, so it's just x when x is less than 3. So this integral, 2 to 5, becomes an integral from 2 to 3, in which case it's this case, right? X less than 3. In that case, you integrate x. and from 3 to 5 you integrate 6 minus x. So that's how you can do this calculation in theory, but you know, this takes a lot more effort than simply just drawing the graph and just doing geometry. So if you think that I'm doing a harder way, don't be fooled. It's much harder going this way. Okay, so hopefully you got convinced that my method is much better. Okay, here we have x squared minus x integral from -2 to 3. That's a straightforward integration question. Integral of x squared, you add 1 to the exponent, put the reciprocal in front. See, this is x to the first power, so adding 1 gives you 2, and put the reciprocal. And you plug in 3 and -2. So 1/3 3 cubed minus 1/2 3 squared minus 1/3 -2 cubed minus 1/2 -2 squared. Okay, and you know, the number one place where people make mistakes is they forget this parenthesis, and if they forget the parenthesis, they make a minus mistake. Hopefully you don't make that mistake. Okay, so 3 to the third power is 27, divided by 3, that's 9. 3 squared is 9, so 9 over 2. Okay, minus -2 cubed is -8. -2 squared is +4. 4 divided by 2 is 2. So you end up with 9 minus 9/2 is just 9/2. Minus minus would be +8 over 3 plus 2. So let's put everything over 6 so we can have common denominators. So you multiply 3 top and bottom. 3 times 9 is 27. Plus for this one you multiply 2 top and bottom, so that's 16 over 6. And then you multiply 6 and divide by 6, so that's 12. And that gives you 6 plus 2 is 8, 8 plus 7 is 5, and then 55 over 6 would be the final answer. Okay, I don't like that 5, so let me change that, and there you go, that's the answer. Okay, now here's another question that uses geometry. This antiderivative is actually quite hard. You need something called inverse trig substitution to actually find the antiderivative. So if you're curious, you might use some websites such as like Wolfram Alpha or integrate.com to look at the antiderivative of this, and it's going to give you something really horrible, something with sine inverse function in it. So that's definitely not what I'm asking you to do here. You should draw the graph. So how do you draw the graph of y equals the square root of 25 minus x squared? Well, first you square both sides and add x squared, then it becomes something very familiar, which is x squared plus y squared equal to 5 squared. And we've learned that x squared plus y squared equal to r squared gives you the circle of radius 5, right? But because y is just square roots are never negative, so y is just always 0 or positive, so you don't get the full circle, you only get the top half of the circle. So the graph of this would be just top half of the circle. So the graph would be half a circle of radius 5. And on here, you're integrating from 0 to 5, so you have this graph, and you're integrating over this interval 0 to 5, and you only have this. So that's this integral. So what is that? That's a quarter of a circle, right? So this would be a quarter of a circle of radius 5, and we use the formula pi r squared. So pi r squared is the area formula for a circle, okay? So we use this, and we use that, and 5 squared is 25, so the answer would be 25 over 4 pi.